Hello everyone, welcome to Atazia Learning Center. Today we will learn about kinetic theory and change of state. These are the learning objectives of these lessons, both for core and extended program. As we know that matter can exist as a solid, a liquid, or a gas, they also can change from one state to another. This change known as change of state. Melting, freezing, boiling, and condensation are examples of change of state. These are the complete change of states. The change from solid to liquid is called melting. Then the change from liquid to solid is called freezing. The change from liquid to gas is called evaporation, and gas to liquid is called condensation. Then solid to gas is called sublimation, and gas to solid is called deposition. When a substance changes from a solid to a liquid, we say that it is melting. What happens to the particle of solid that is heated until it melts? As heat energy is supplied, the particle vibrates faster until the vibration of the particle overcomes the attractive forces between them. Then the particles begin to break away from their fixed positions. And lastly, the particles slide over one another. The substance is now a liquid. They are no longer have a fixed position. How does the temperature of a solid change when it melts? For example, here there is a process from A to B, which is the solid heats up. The temperature of the solid increases until it reaches point B. It is a melting point. At point B, the solid begins to melt. Next, the process from B to C. It is an area where a mixture of solid and liquid exists. During the melting process, the temperature of the substance remains constant even though heating continues. All the heat energy taken in by the particle is used to overcome the forces of attraction between particles. Temperature during B to C change is called melting point. Next is the process from C to D, which is the liquid heats up. At point C and beyond, all the solid has melted and the temperature of the liquid rises as heating continues. What happened to the particle of liquid that is cooled until it freezes? The particle lose kinetic energy and begin to move more slowly. Then when the temperature is low enough, some of the particles start to settle into fixed position. Then finally, all the particles settle into fixed position. The substance is now a solid. Okay, this is the cooling curve. Yeah. How does the temperature of a liquid change when it cools? Yeah, from process P to Q, the liquid cools. The temperature of the liquid drops until it reaches point Q, the freezing point of naphthalene, for example. At point Q, the liquid starts to freeze. Then the process Q to R, the liquid freezes. During the freezing process, the temperature of substance remains the same even though the cooling continues. The temperature during QR change is called freezing point. A mixture of liquid and solid exists here. And lastly, the change of R to S, the solid cools. At point R and beyond, the substance has solidified. The temperature of the solid continues to drop as it cools. Boiling. As the liquid is heated, the particles gain kinetic energy and start to move faster. Then, eventually, the particles have enough energy to overcome the forces holding them together. Then they spread far apart and move rapidly in all directions. The substance is now a gas. How does the temperature of liquid change when it boils? When a liquid is heated, its temperature increases till its boiling point is reached. Here, it boils and changes into a vapor. The temperature remains constant till all the liquid has boiled off. Evaporation occurs because some particles have enough energy to escape as a gas from the surface of the liquid. Liquid can evaporate quickly at a room temperature are called volatile liquids. Petrol, perfumes, alcohol are examples of volatile liquids. What happens to the particle of a gas when it condenses? Heat energy is given out during condensation. As the temperature drops, the gas particles lose energy and move more slowly. Eventually, the movement of the particle becomes slow enough for the gas to change into a liquid. Next is sublimation and deposition. When a substance sublimes, it changes directly from a solid to a gas. Iodine, ammonium chloride, and dry ice, solid carbon dioxide, sublime. A substance sublimes because the forces between the particles in the liquid state are too weak to remain in this state. The reverse process, gas to solid, is called deposition. Diffusion. When a bottle of perfume is left open for some time, the scent of the perfume soon spreads throughout the entire room. Similarly, if your mother is cooking curry in the kitchen, you will soon be able to detect the smells of spices in every room. The process by which particles move freely to fill up any available space is called diffusion. How do we show diffusion? We can show diffusion in the laboratory by placing a gas jar of air over a gas jar containing a bromine vapor. A few minutes after the cover is removed, the gas in both gas jars looks the same. Why does diffusion occur? Both air and bromine are made up of tiny particles moving at random. The bromine particles diffuse or spread out into the spaces between the air particles and vice versa. When the gas looks the same in both gas jars, it means that the particles of both gases are evenly spread. We say that homogeneous mixture of air and bromine is formed. Do all gases diffuse at the same rate? The mass of a gas particle is called its relative molecular mass. The smaller the relative molecular mass of the gas, the lighter it is, and the faster it moves. The table here shows the molecular masses of some gases. Hydrogen's Mr 2, oxygen, the Mr is 32, and carbon dioxide, the Mr is 44. How do we show the rate of diffusion is affected by Mr? We can do so using the setup shown here. There is a box contains of cotton wool soaked in one part is soaked in concentrated ammonia solution, and the other part is cotton wool soaked in concentrated hydrochloric acid. Then we left them. After some times, they will form a fumes, yeah, around the middle of the jar. The fume is ammonium chloride fumes, and it is closer to hydrochloric acid. Why is it happen? The Mr of ammonia is 17, while the Mr of hydrochloric acid is 36.5. Ammonia travels faster, hence the ammonium chloride is formed further from ammonia. Diffusion also takes place in liquids. Small crystal of potassium manganate 7 is introduced into a beaker of distilled water. A deep purple solution forms at the bottom of the beaker. Diffusion slowly takes place until the solution becomes uniformly purple. The effect of temperature on the rate of diffusion. What would you observe if experiment was repeated using boiling water? The solution would become uniformly purple within a much shorter time. When temperature increases, the rate of diffusion also increases. This is because the kinetic energy of particle is also increased when temperature increases. That's all video for today. Please subscribe, like, and comment. Thank you.